Now let's discuss question number 48. It states a vertical pole of height 10 meters stands at the corner of a rectangular field. The angle of elevation of its top from the farthest corner is 30 degrees, while that from the another corner is 60 degrees. The area of the rectangular field needs to be obtained out of these four options. So let's draw a figure to solve this. Very first here we have drawn this figure, and in this figure here ABCD represents the rectangular field. Here OC is that pillar, and here its height is given to be 10 meter, and according to this question you are taking here the angle of elevation from top of the farthest corner to be 30 degrees. And as you have pole at this corner C, farthest corner is A, so here from this point angle of elevation, that is angle CAO, is 30 degrees, and its angle of elevation from another point, that is D, is given to be 60 degrees. Let's consider the sides of the rectangle to be Z and Y and its diagonal to be X. Considering that, if you consider triangle OAC, that is this triangle, and you find here value of tan 30 degrees. As you know, tan is the ratio perpendicular and base, so you will get here OC upon AC. As you have considered AC to be X, this will help you out to obtain this as equal to 10 upon X. And on solving this, as you know, the value of tan 30 degrees is equal to 1 upon root 3. You get the value of X is equal to 10 root 3. In the same way, when you will consider here this triangle OCD, where tan 60 degrees is equal to OC by CD, you get here 10 upon Y, because we have considered AB to be Y, so opposite side of the rectangle CD will be also Y. Now, as you know, the value of tan 60 degrees, this is equal to root 3. Using that, you will obtain here the value of Y equal to 10 upon root 3. Now, as you know the value of X and Y, so this is a rectangular field and this is definitely a right angle triangle. So, you can apply here Pythagoras theorem in this triangle ADC, and in the triangle ADC you can write using the Pythagoras theorem that x square is equal to y square plus z square. On further solving that, you get that z square is equal to x square minus y square, that's why z square is equal to 800 upon 3, because you have substituted here the value of this x and y. So, this can be further implied that z square is equal to x square minus y square. On substituting x as 10 root 3 and y as 10 upon root 3, you get a simplified value of z equal to 20 root 2 upon root 3. Now, as z has been obtained and y is already known to you, in this figure you can definitely say now that y is equal to 10 upon root 3, and now you have also obtained this z is equal to 20 root 2 upon root 3. So, in this question, as you need to obtain area of this rectangular field, and as you know area of rectangle is length into breadth, that's why when you will be solving this, you can write here area of field is given by z into y, which is equal to 20 root 2 upon root 3 into 10 upon root 3, which you can easily simplify to get your required answer as 200 root 2 upon 3. So, let's obtain the correct answer for this question. As you have obtained the correct answer for this question, that is 200 root 2 upon 3, which is option number 1. So, required answer for this question is option number 1. Now, let's move on to our next question. Now, let's solve question number 49. It states here a circle is inscribed in a square and square is circumscribed by another circle. So, this is a case where we have a circle and a square is circumscribing that circle and another circle is circumscribing that square. So, basically you have here 3 figures and you need to obtain the ratio of areas of inner circle to outer circle. So, very first let's consider this diagram where we can consider the side of the square to be A. If you consider the side of the square to be A, then the diameter of the inner circle will be equal to the side of the square. So its radius will be half of the side of the square, that is a by 2. Moreover, when you consider the diagonal of this square, this is equal to the diameter of the larger circle. So if diagonal of the square is considered, its side is a, its diagonal will be a root 2. So the diameter of the outer circle will be also a root 2 and its radius will be a root 2 by 2, that is a upon root 2. So now you know the radius of the outer circle and inner circle. Let's obtain the required ratio of the area of outer circle and inner circle. As per question, you need the ratio of area of inner circle and outer circle. This is pi a upon 2 whole square upon pi a upon root 2 whole square. When you will be simplifying this, pi gets cancelled, moreover a square gets cancelled, and you are obtaining here the value equal to 1 upon 4 upon 1 upon 2, which can be further simplified, and the required final ratio is here 1:2. So out of these 4 given options, you can clearly say now that the required ratio of the areas of inner circle and outer circle is definitely 1:2. So answer for this question is option number 1. Now let's move on to our next question.